Linear regression. Predicting a value, like a price.
Right. The machine starts by trying to fit a straight line, and that line is defined entirely by its parameters, its weights, the verpal.
Those weights determine the slope and where it starts on the graph, the intercept.
Exactly. And one of those weights, theta naught, is the bias. It's like a baseline prediction even if all your inputs are 0. Finding the best set of those weights, that's the whole game.
So, okay, the machine picks some weights, maybe randomly at first. How does it know how far off it is? How does it evaluate?
Good question. That takes us to evaluation for regression. The standard approach is squared error loss.
Squared error. So you take the real answer, subtract the machine's prediction.
And square the difference.
Why square it?
Well, 2 reasons, really. 1, it makes all errors positive, so they don't cancel out. A negative error is still an error.
And 2.
It penalizes big mistakes much more heavily than small ones. Being off by 10 is way worse than being off by 1 squared.
Right. It really pushes the model away from those huge misses.
Precisely. And when you add up all those squared errors for every single example in your data, you get the total cost function.
J of theta equals 1 over 2m times the sum from I equals 1 to m.
Okay, the setup.
Of the quantity AGH theta of x superscript I minus y superscript I squared.
Optimization is just finding the value that makes this total cost as small as possible.
Okay, but the real world isn't always straight lines. What about curves? Data often curves. How does AI handle that if the tools are based on linear algebra?